This video is a continuation of section 3.7 on the chain rule, and I left you last with this example here that we're trying to take the derivative of. So you actually have a product rule happening here, and I chose this example because it's pretty complicated. We have the product rule and the chain rule. So the product part comes from the fact that you've got an x being multiplied by the square root of 5 minus x squared. So we'll start with the product rule. But when I have to take the derivative of this second function, we'll have to use the chain rule. So try to follow me here. Alright, product rule says, take the first function, x, multiply by the derivative of the second function. Here's where it gets tricky. I want the derivative of this function. It might be nice to think about this function as 5 minus x squared to the 1/2 as opposed to a square root. That way we can use the power rule and the chain rule. So I'm going to take the derivative of the outer function, which is going to be 1/2 times 5 minus x squared to the negative 1/2. So I'm just using the power rule here, decreasing this power by 1, and then having the g of x, the inner function, being plugged inside. But I'm not done, because here's where the chain rule comes into play. I did my power rule of the outer function. Now I also need to multiply it by the derivative of the inner function. The derivative of 5 is 0. Negative x squared requires the power rule again, so that's going to be negative 2x. So let's just remind ourselves where we are in terms of the product rule. The first function times the derivative of the second function. Now I need the second function as is, times the derivative of the first function. And the derivative of the first function is just 1. So that's really your derivative. It's just not clean enough. We've got to combine some things. So first of all, we've got two terms. This whole thing here is one term because everything's being multiplied. And then over here we have a second term. So in this term here, there's a couple things I can combine. 1/2 times negative 2, as well as this x here times that x there. So in simplifying that part, I get negative x squared, and then this right here, 5 minus x squared to the negative 1/2, is the same as 1 over the square root of 5 minus x squared. So in my denominator, I'll have that square root piece. I'm going to add that to the square root of 5 minus x squared. So this is my derivative. I'm actually going to take one more step in combining them. If I get a common denominator and add these, it'll actually make my function a little bit cleaner here. So my common denominator is going to be this denominator, square root of 5 minus x squared. In the first fraction, I don't have to multiply by it, but in my second fraction, I do. So I'm going to multiply by the square root of 5 minus x squared on the top and on the bottom, which is what makes it legal. And look what's going to happen. Now I have a common denominator. I can combine these numerators, but also I'm squaring a square root, which cancels out, and so I have negative x squared plus 5 minus x squared. And the denominator stays the same. Alright, finishing it up. Negative 2x squared plus 5 over the square root of 5 minus x squared. And there's my derivative. So that was pretty complicated. Product rule, chain rule, power rules, square roots, pretty much everything in one example. Now I mentioned in the last video that the goal was really to write the equation of a tangent line using the chain rule, and we haven't done that. But I just wanted to focus on taking the derivative of this function first. So let's do the next piece. So again, what we want to do is write the equation of the tangent line. Write the equation of the tangent line. of the function y equals, x times the square root of 5 minus x squared. So the same function that we just worked on a second ago. And it's going to be at the point 1 comma 2. So remember, if we're writing the equation of the tangent line, we need two things. We need the slope at the point 1, 2, and we need the point, which is 1, 2. So let's remind ourselves how it is that we get the slope. Well, the slope is the derivative. So we would want to find y prime, and luckily we did that. I just went through the steps of how to find the derivative using that chain rule. So I'm just going to recopy the exact same derivative that we found a second ago. And I need to find that slope specifically at the point 1, 2. So in this case, the x is the only value that we need. So I'm evaluating it at x equals 1. This is a little notation that I don't think I've used yet, but that bar just means take this function and evaluate it at x equals 1. So I'm just plugging 1 into that function so that we can find specifically the slope at that point, as opposed to the regular derivative, which represents the slope at any point. Alright, so on the top, 1 squared is 1, 5 minus 2 is 3, and then on the bottom, 5 minus 1 squared is going to give me 4. Take the square root, I get 2. So it looks like 3/2 is my slope at that specific point, and I also need the point in order to use the point slope formula. So y minus y1 equals m times x minus x1. Let's plug in all the pieces to that puzzle. So my y1 value is the y coordinate of my point, which was given, so that'll be 2. My slope was found through getting the derivative and plugging x equals 1 into that derivative. And my x1 is the x coordinate of my given point. So y minus 2 equals 3/2 times x minus 1. And that is a good answer. The only thing is that when you guys use MyMathLab, a lot of times it'll prompt you to give your answer like this, where it'll start with the y equals part and the blank is the rest of it being filled in. So you may have to distribute this and then add the 2 over in order to get into y equals form. So I can do that here on the side just to see what we would have. So we would have a 3/2 x component, and then here the y-intercept is negative 3/2 plus 2, which I would want to get a common denominator in order to add together. And negative 3/2 plus 4/2 is going to be a 1/2. So in y equals form, that would be the equation of our tangent line. Alright, so from here it's just about practicing using that chain rule, especially when it's mixed up with the product rule and the power rule and square roots and all of these other things. So, so that'll be one component, and then also writing the equation of the tangent line once you've used that chain rule to find the derivative. Alright, so that'll be it for this section, and there'll be another video coming up for implicit differentiation, which is the next section.